Hi, welcome to another class with Physics Anchor. Today we have some questions from JAMB Past questions under the topic motion, and we have 3 questions on the board to deal with. So let's get started. Question number 1, a body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third second? So in the last video, I explained the question of this nature. So any question of this nature, I already gave you the approach to solving them. So once you understand the approach, it's very hard for you to choose a wrong answer or for you to get a wrong answer. So let's give it the same approach. First, in our culture, we write out the parameters that we have from rest. So u equals to 0, and then it moves with uniform acceleration of this. So that means that acceleration equals to 6 meters per second squared. So what distance does it cover in the third second? So they want us to find s third. Okay, so let's call it distance that in the third seconds. So in other words, what they are telling us is that the journey actually took about 3 seconds. Okay, the journey took place for about 3 seconds. Okay, this body moves for the maximum of 3 seconds, but they are only interested in us finding the distance it covered in the third seconds. So in the third seconds now, we can draw something like this. I drew this in the last video. Let's say from rest, that is 0, 1, 2, 3. So the journey took place for 3 seconds, but we can find a distance for the first 2 seconds and find a distance for the whole journey, that's for 3 seconds. So if you're able to know this distance and we know this distance, okay, this distance, you know, if we subtract this distance from this distance, it's going to give us this distance, and that's the distance they want us to find. They want us to find the distance it covered in the third seconds. The third seconds happened between the 2 seconds and the 3 seconds. So the third seconds is between this. That's 3 minus 2. So the third seconds is between this lap. So if you find the distance for the first 2 seconds, find the distance for the 3 seconds. So this one minus this will give us this one. Okay, so it's just the arithmetic. So we can actually do that now. So we say that when that's t equals to what, 2 seconds now, that will be s2. Let's call it s2. We are using the formula s equals to ut plus half at squared based on the parameters given. Okay, because we have u, we have t, we have a, and we are looking for s. Nothing concerns us with what final velocity, so we don't need any formula that will consist of final velocity. So we have this. So since our u is actually what, 0, so that will be times this plus half a. Our a is 6. Okay, t squared. Our t here is actually 2, so that will be 2 squared. So that will be 0. Half times 6 will be 3, times 2 squared will be 4, and that will be 12 meters. So the distance covered for the first 2 seconds is 12 meters. Now when t equals to 3 seconds now, so that will be s3 equals to 0 half 0 bracket 3, which is the time now, plus half a is still 6. Now our t is now 3, that's 3 squared. So that will give us 3 times 9, which is 3 squared, and that will give us 27 meters. So our s third seconds, that's the distance for the third seconds now, will be s3 minus s2, and that will give us 27, which is the s3, minus 12, which is the s2. Okay, that will give us 15 meters. So let's go to our options. So the options here, A is the correct answer. So you can see the approach is very simple once you understand the approach. So no matter how they twist the question, in as much it is the question of this pattern, you will always what get the right answer. So please take note of that. So without wasting time, let's move to question number 2. Question number 2. Okay, in question number 2, we have a particle starts from rest. From rest, that's u equals to 0, and moves with a constant acceleration of 0.5 meter per second squared. So that means that a is equals to 0.5 meter per second squared. Okay, the distance covered by the particle in 10 seconds is dash. So in other words, t is equals to 10 seconds. They are asking us the distance. Okay, the same formula that we just used, plus half at squared. This is very straightforward. It's a very straightforward question. So s equals to 0 bracket 10 plus half. Our a is 0.5 times t, which is 10 squared. This is 0, and that will be half. This 0.5, you can also do it as half, because 0.5 is 1 over 2 also, times 10 squared is what? 100. So we can say that 2 here 1, 2 here 50, 2 here 1, 2 here 25. So our distance covered is 25 meter. In our option, okay, C is the correct option. That's 25 meter. I hope you understand that. Okay, so you should learn how to work with time also. It's very important. It's just for the sake of explanation. That's why I'm taking things slow. So you should be able to think fast and analyze question and solve it to save time. Number 3, 2 points on a velocity time graph have coordinates 5 seconds, 10 meter per second, and 20 seconds, 20 meter per second. Calculate the mean, okay, acceleration between the 2 points. So you should be familiar with a velocity time graph. Okay, so this is how what they just give us. This is how it looks like. So let's see this as a straight line graph where we have velocity against time. So the way this place will look like is that you know that the slope of velocity time graph is actually the acceleration. The slope or the gradient is acceleration. So what they gave us is something like this. Okay, in the first one we have 5 seconds, 10 meter per second square. In other words, when you trace to this place, you trace to this place. This place is a the velocity aspect is 10, so that is 10. Okay, while what the distance, the time is 5. Okay, the other one also, okay, trace this one just like you are finding your gradient. Okay, that one is 20 seconds, so the time is 20, and your acceleration is the time is 20. Okay, acceleration is also 20, so acceleration is also 20. Okay, so that is that. So acceleration is equals to change in the velocity. Okay, that's v minus u over change in time also. So change in time, that's t2 minus t1. Okay, so that will give us the final velocity here is 20 minus the initial here, which is what? 10. Okay, over t2, which is 20, minus t1 minus 5. So that will give us 10 over 15. Okay, and that will give us 5 here 2, 5 here 3. That will give me 0.666666. So I can take it, look at the option. Okay, they did everything to 2 decimal places. So it will just be 67, okay, meter per second square. Okay, so let's check the option. So the option A is the correct answer, 0.67 meter per second squared. Okay, and that is the end to the 3 questions we have on the board. I hope you understand all the questions that we have just solved. Please share out this video with other students around you. Subscribe, hit the notification bell, hit the like button, comment. Let me know how well you are studying and how well you are coping with all the classes I've been dropping. I wish you all the very best in your examinations. Bye for now.